In this lecture, we're going to learn about shared pointers. And this is another kind of smart pointer we have in C++. The special thing about this pointer is that we can have multiple pointers pointing to the same data that we have in memory. For example, we have pointer 1, which is a shared pointer. It is pointing to our data. We have pointer 2, which is also pointing to the same data. We have pointer 3, which is pointing to the same data. We have pointer 4, which is pointing to the same data. One special thing about shared pointers is that there is some kind of reference count, which is going to keep track of how many pointers actually point to the same data. For example, if we set up pointer 1 here, the reference count is going to be 1. If we set up pointer 2, the reference count is going to go up and be 2. If we set up pointer 3, the reference count is going to be 3. If we set up pointer 4 here, the reference count is going to go to 4. If any of these pointers goes out of scope, the reference count is going to decrement. For example, if pointer 3 here goes out of scope, the reference count is going to decrement and be 3. If, for example, pointer 1 here goes out of scope, then the reference count is going to decrement and be 2. If pointer 2 goes out of scope, for example, the reference count is going to go down to 1 because we still have only one pointer pointing to the data. And then when pointer 4 goes out of scope, the reference count is going to go down to 0. And that's when the data in memory is going to be wiped out and released. So shared pointers are only going to release the memory when the reference count goes to 0. At any point when we have a single pointer or more pointers pointing to the data is not going to be released if one of those pointers goes out of scope. This is the main design principle of shared pointers here. Okay, so now that you know the basic principle behind shared pointers, let's see how we can use them in C++ code. Here we have a simple example with shared pointers to fundamental types. The syntax you use is really the same to unique pointers. You just say shared pointer here. It's going to be pointing to int. You say the variable name and then you initialize your data using the new operator here. And this is going to give you a pointer, a shared pointer, pointing to this data in memory. Once you have the shared pointer, you can really use it like you use any other pointer. For example, you can dereference and put another value inside. And if you print, you're going to get the new data printed out as you see here. You can print the reference count using the useCount method. This is really important. Please remember this. And this is the syntax you use here. So once we have the shared pointer set up, we can do all kinds of crazy things with it. For example, we can copy the data that we have in this pointer and copy that into another pointer. And copies are allowed because we can have multiple shared pointers pointing to the same data. We just looked at that in the previous slide. So the syntax here is going to copy the data we have in shared pointer 1, and shared pointer 2 is basically going to be pointing to the same data as shared pointer 2. What this is going to do is going to push the reference count to 2 because now we have 2 pointers pointing to the same piece of data in memory. This is what we mean here. If we go through pointer 2, we're going to get the same data that is pointed to by pointer 1. So we're going to print 20 here. And we can go through pointer 2 and change the data that is pointed to. If we do this and print the data, now we're going to get 70. This is going to work. And if we print the useCount, we're going to get 2 here because we have 2 pointers pointing to the same data in memory. You should really keep this in mind. Okay, we can keep setting up other pointers. So for example, here we can set up pointer 3, which is going to point to the same data that is pointed to by pointer 1. Notice that on top here, we have set up a shared pointer and not initialized that. This is going to initialize the pointer to null pointer, if I remember correctly. And if we assign pointer 1 to pointer 3, as we are doing here, this is going to push the reference count to 3 because now pointer 1, pointer 2, and pointer 3 are pointing to the same data in memory. And I want you to keep this in mind. Another thing we can do is set up another pointer and initialize that with null pointer and then explicitly assign pointer 1 to pointer 4 as we do here. This is going to push the reference count to 4 because now we will have 4 pointers pointing to the same data in memory. If we use the syntax here to set up another pointer, pointer 5, pointing to the same data in memory, the reference count is going to go to 5. And here my goal is really to show you different syntaxes we can use to copy shared pointers, because you need to see all these things here. Okay, at this point we can print the data through pointer 5. We're going to have the same data printed out. We can go through pointer 5 and modify the data that is pointed to by these pointers. And now if we print through pointer 5, as we are doing on this line here, we're going to get 100 printed out. And this is what you're going to see if we run this program here. At this point, if we print the use count through all these pointers, we're going to get 5 printed out, because we have 5 pointers pointing to the same data in memory. Okay, now if we have these pointers and we happen to reset one of those pointers, what is going to happen? That pointer is going to be reset to null pointer. It's going to be pointing to null pointer, but that's also going to decrement the reference count, because that pointer is no longer going to be pointing to our data in memory. So this is what is going to happen here. All the other pointers are going to be pointing to the same memory, but pointer 5, if we print the reference count, we're going to get 0 because it's really not pointing anywhere. But for the other pointers here, we're going to get 4 because we have 4 pointers left that point to the same memory location. Another thing you should know is that we can go through the get method and get the row pointer that is managed by our shared pointer, and we can really use that in our application if that's what we want in whatever we are designing with C++. We can also cast this to bool, and what this is going to do, it's going to make it usable in if statements like this. We can check and see if the pointer is pointing somewhere valid. If it is pointing somewhere valid, we're going to know that, and we're going to print that here. If it is just a null pointer, we're going to know that, and we're going to print that here. This is something you can do in your C++ applications. Another thing we can do is use make shared, which is a facility that is going to help us avoid using the new operator directly. For example, here, this is going to set up a new piece of memory that is going to be pointing to a location containing the 55 here. And we're going to be managing that piece of memory through the shared pointer here. We can also set up another shared pointer, which is going to be pointing to a dog object. This is the syntax you can use. Once you have the shared pointer, you can really use it. For example, here we are dereferencing that and printing the data. Here we are calling a method on the dog object. You can really do all kinds of crazy things. Down here, you see that we can print the reference count, and this is going to give us however many pointers we have pointing to the same memory location. We can also make copies. For example, here you see we have a pointer to int, and we are going to put in the same data we had in pointer 6 here. We can do the same for dog pointers, and this is going to work. This is just going to increment the use count. And if we print that, we're going to see that we have more pointers pointing to the same data in memory. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is shared pointers. We're going to grab our template project pretty quick and put that in place. And we're going to grab the dog class from a previous lecture because we're going to be reusing this. We don't want to type all these things. So let's save ourselves some time. And we are going to open this little guy in Visual Studio Code. This is going to open our project, which is shared pointers. And we're going to remove whatever we don't need here. We can close the left sidebar, and we're going to bring in the memory header to give us access to shared pointers. And we're going to include our dog class because we're going to use that in a minute. The first thing I want to do is to explore shared pointers in the context of fundamental types. And what I am going to do, I am going to put in a nested scope, and we are going to set up a shared pointer, which is going to be pointing to an integer, just like you see here. So the syntax is std shared pointer. You're going to put a pair of angle brackets, and then you're going to specify the type inside. After that, you're going to say the variable name, and then you're going to initialize your pointer with the new operator as you see here. Once we do this, we can use this pointer like we use any other pointer. For example, we can dereference that as you see here. We can assign a new value to the pointer. And if we do that, we're going to see that the new data is going to be reflected in our pointer here. We can even print the use count. In this case, we're going to only have one pointer pointing to this data in memory. So the use count should be 1, as we see here. If we print, this is what we're going to get. So for this to work, make sure you have the memory header included. And we're going to try and build this program here. We're going to pass this through GCC. You're going to see that the build is good. We're going to bring up a terminal window, or a PowerShell window, I should say. We're going to clear and run Rooster. And we're going to see that first, the value is going to be 20 because that's what we initialized our memory here with. But we have changed our data through the shared pointer here. And the new data is going to be 40. And the use count is 1 because we only have one shared pointer pointing to our data in memory here. And you should really understand this. We're going to put in a separator. And we are going to go down and show you that it is possible to copy shared pointers. Let's take out our terminal window here. I think we can close all this. We don't need all this here now. And we're going to go down and put in our code. We are going to set up another shared pointer to int. And we are going to initialize that pointer with the other pointer we had before. So pointer 2 is being initialized with pointer 1 here. And this is going to bring our use count to 2. So we can go through pointer 2 and print whatever data we had in pointer 1. We're going to get 40 in this case. We can go through pointer 2 and change the data. And the data is going to change to 70, as you are going to see in a minute. And this is going to bring the use count to 2. If we go through pointer 1 or pointer 2 to print the use count, we're going to get a 2 because now we have 2 pointers pointing to the same data in memory. Let's try and build this program. You're going to see that the build is good. We can bring up our PowerShell window. We can bring up another one, no problem. We're going to clear and run Rooster. Now you see that if we print the data, we're going to get a 40, which is what we had before. But if we go through pointer 2 and modify the data is going to change to 70. Even if we change this to pointer 1, PTR1, this is going to give us the same data because these two guys are pointing to the same memory location. So let's build again and show you that. The build is going to be good, so we can clear and run Rooster. You're going to see that the data has changed to 70. Let's bring this back to pointer 2 because I don't want this to be confusing to you. And you see that the use counter from pointer 1 is 2. The use count from pointer 2 is 2. We have 2 pointers pointing to the same memory location, and these are shared pointers. Let's go down and show you that there are a few other ways we can initialize our shared pointers. Let's go down and put in the code, and then we're going to explain this line by line. So let's take this out because it is just going to give us noise output. We're going to see that we can set up a shared pointer like this and not initialize this. This is going to initialize it to null pointer implicitly. And if we make a copy like this, this is going to bring our use count to 3 because we now have 3 pointers pointing to the same memory location. We can do something like this and explicitly initialize our pointer to null pointer. And if we make a copy like we are doing on line 38, we're going to bring the use count to 4 because now we have 4 pointers pointing to the same memory location. We can do something like we have on line 40 here, and this is going to bring us to a use count of 5. Now, if we go through pointer 5 and print the data, we're going to get the data in our memory location. Let's go up and see the last piece of data we put in. I think it is the 70 here on line 26. So if we print the data here, we're going to get 70 printed down. And if we change the data through pointer 5 on line 43 here, we're going to get 100 inside, and then we're going to see that printed out here. After that, we're going to print our use count, and we're going to go through different pointers to get the use count. You're going to see that we have 5 pointers pointing to the same memory location. Let's go down and put in a separator here. We're going to do stdc out. We're going to put in a pair of dashes, just like this. This is going to do. And we're going to say stdndl. And then we're going to build this code here. We're going to use GCC to do that. Let's bring up our window here, and we're going to clear. You see that the build is good. We're going to bring up a terminal, and we're going to run Rooster. Now we're going to see that after we set up all the other pointers that we just set up here, we're going to print up the separator here. And then if we print the data, we're going to get 70, which is what we have on line 43 here. Then we change the data on line 44. If we print again, we're going to get 100 printed out. And then we're going to print the use count through all the pointers. From pointer 1 all the way to 5, you see that the use count is 5. This is something you should be aware of because we can have multiple pointers, or to be specific, multiple shared pointers pointing to the same memory location. And each new shared pointer you set up is going to increment the reference count or the use count, and that's what we see here. Now we have 5 pointers and we have a reference count of 5. It is also possible to use a shared pointer to manage already existing memory. Let's go down and put in the code to show this off a little bit. We have a row pointer pointing to an integer and the value inside is 33, but we can take over this memory location with a shared pointer with a syntax like this. We have our shared pointer initialized with a row pointer. This is going to take over the job of managing this memory location, and it is going to be this shared pointer which is going to be managing our memory here. If we print the data through our shared pointer, we're going to see that printed out. And if we print the use count here, we're going to see that the use count is 1 for this memory location here. Please be careful. This is not the same memory location as we had above because we are calling the new operator here. This is a new piece of memory. You need to be aware of this. Let's go down and say that. We can just grab the text here and put that inside because I don't want to type all this. We just want to be able to see good output on the console, and this is going to help. And we can put a separator here. Let's say stdc out properly, put in colons, not quotes. And we're going to do std and put in a pair of separators. This is going to be better. And if we build and run this program, we're going to see that pointer 6 is pointing to the 33 value here. We can clear and run rooster, and that's what we have here. And if we try and see what the row pointer is pointing to, we can try and do that. This is a good learning opportunity, so we're going to print that out. We're going to print row pointer. That's what we can say here. And we're going to print that out. That's going to be int ptr row. That's what we had. And let's see what we have inside. I think setting up this thing here we have on lines 59 is not going to reset the row pointer. So we have to explicitly reset that. Let's see if I am right. We're going to run the task to build with GCC. The build is going to be good for sure. We can clear and run rooster. Now we see that the row pointer is still pointing to the same location. And this says that you have to reset this pointer yourself. Let's make sure and really show you that it is pointing to the same location as the shared pointer. We can do that through the get method. We're going to say int ptr6 get. We can say this. So we're going to put a colon and put in our code here. You see that we can call the get method to get whatever is pointed to by this pointer. And if we build and run this program, we should see that the row pointer and the shared pointer are pointing to the same memory location. If we run rooster, we're going to see the exact same thing here. The row pointer is pointing to a memory address that ends in B30. The shared pointer is pointing to the same memory location. And you should really be careful whenever you do something like this. It is a good practice to just go in and set the row pointer to null explicitly. Let's do that. We're going to say int ptr and we're going to say row because that's what we want to change here. And we're going to make it point to null pointer. Now, if we build and run this program, we should see something more safe. Because if you use the shared pointer, you want the shared pointer to be managing your memory. Now you see that the row pointer has changed to 0, and the shared pointer is now managing our memory, and this is really cool. This is what we want. The next thing I want you to see is that if you reset any of the pointers by calling the reset method, this is going to decrement the reference count for the other pointers, but it is going to reset the pointer you just called but it is going to zero out the pointer you just called the reset method on. So after we call reset, all the other pointers are going to have a reference count of 4 because we have 4 pointers left pointing to the same memory location. But pointer 5 is going to be pointing to null pointer. It's going to be reset, and its reference count is going to be 0 because it is really not pointing anywhere. This is what we're going to get here. Another thing we can do, for example, here is print where the pointer 5 is pointing. We can do that. We can say stdc out int ptr5 get. We can do that, and we're going to print this out on the console, ptr, let's say 5, and call the get method. We can do that, and if we will and run this program, we should see this printed out. The build is good. We can go up and clear and run Rooster. Now we're going to see that after we reset, the reference count is going to be 4 for the other pointers, but for pointer 5, the reference count is going to be 0 because it is not pointing anywhere now. And if we print the address where it is pointing, we're going to get 0. And this is saying that it is just a null pointer. It is not pointing anywhere. Another thing I want you to see is that shared pointers are castable to bool. For example, we can do something like what you see on line 86 and 87 here. We can static cast these pointers to bool. And we can go through the get method to get what is pointed to. You already know this. And we can use these pointers in if statements, just like you see on line 89 here. So let's build and run this. The build is going to be good. We can clear and run Rooster. And we're going to see the last pair of outputs here. We're going to see that we can cast to bool. Int pointer 4 is pointing to this address. Int pointer 4 get is going to be pointing to the same address. So if we print like we do here, we're going to get the address printed out. If we go through the get method, we're going to get the same address printed out. This is really interesting. We can cast the pointers to bool, and if we cast them, we're going to get true if the pointer is pointing to something valid. We're going to get a false if the pointer is pointing to null pointer. This is what you see here. Pointer 5 is not pointing to something valid because we zeroed it out on top here. And we can go through if statements to really test and see these things here. For example, we're going to see that pointer 4 is pointing to something valid, and we're going to see this printed out here. Another thing I want you to see is that as you reset all these pointers, the reference counts are going to go down one by one. So for example, let's go down here and show you that we're going to be printing all the reference counts. And we are going to reset pointer 4. So we're going to say int ptr. I think we can say that. And we're going to say 4. We're going to reset that. If we do this, we're going to see that the reference count is going to go down to 3. And pointer 4 and 5 are going to be having a reference count of 0. Let's say what we are doing here. And if we will then run this program, that's what we're going to see here. We're going to see that the reference count has gone down to 3. And pointer 4 and 5 are pointing to 0. They are pointing to null pointer, so they have a reference count of 0 as you see here. We can also reset the pointer 3. We can just copy this and reuse this piece of code here. I don't want to retype all this. So we're going to go down and print our thing here, and we're going to change it to 3 to mean that we are zeroing out the pointer 3 here. Let's build and run. We're going to go down here and clear and run Rooster. And we're going to see that the reference count is now down to 2. And all the other pointers are zeroed out. So the reference count is 0, as you see for pointer 3, pointer 4, and pointer 5 here. If we reset pointer 2 and 1, all the pointers are going to go down to 0. And the reference count is going to be 0. And the memory that the thing is pointing to is going to be released. We can't really see this with fundamental types, but we're going to do the same thing for Dog objects, and you're going to see that the structure is called when the reference count hits 0 in a minute. So what do we have here? We're going to put a dot to call the reset method. We're going to rebuild the application. And the build is good. We can clear and run Rooster. This is going to give us a reference count of 0 for all the other pointers except pointer 2. So what is going on here? We are coding get and not reset. So let's do that. We're going to build. The build is good. We can clear and run Rooster. This is going to give us a reference count of 0 as we expect here. Okay, so now that we have this in place for fundamental types, we're going to try and see the same thing with custom types. And we're going to be using our dog class to really see the destructors called for this thing here. So we're going to comment out whatever we did with fundamental types here because it is already done. And we're going to go down and do the same thing with a dog object. So let's do that. We're going to go down and say shared pointers with custom types. We are going to put in a nested scope here, and we are going to set up a bunch of shared pointers. Let's do that. We're going to go down and do that. We have a dog object set up here. It is going to be pointed to by a shared pointer, as you see here. We can go through the shared pointer and print information about our dog object. This is going to have a use count of 1 because we have one pointer pointing to this memory location. And we can do a copy as we see on line 11.9 here. And this is going to bring our use count to 2. If we print that, that's what we're going to see on the PowerShell window in a minute here. So let's build and show you this. This is going to call the constructor for our dog object. And when the dog pointers run out of scope, we're going to see the destructors called. This is what we want to see here. And you should see this. Let's build this with GCC. The build is good. We can clear and run Rooster. We're going to see the constructor for a dog called. And then we're going to print information about our dog. The use count is going to be 1, as we see on this line here. And then we're going to make our copy and we're going to print the use counts for dog 1 and dog 2. And we're going to see that the use count is 2. Once we hit the end of the scope here, the shared pointer is going to go out of scope. And then we're going to see the destructor called. And what is going to be happening here, dog pointer 2 is going to go out of scope. The use count is going to go down to 1. Dog pointer 1 is going to go out of scope. The use count is going to go down to 0. And then the memory is going to be released. That's why we see the destructor for our dog object called here. This is really something you should know. We can also do all kinds of crazy initializations to our shared pointers. For example, if we go down here and use the code here, we're going to set up another shared pointer, dog pointer 3. We're going to copy the data in. This is going to bring our use count to 3. We can set up another one and explicitly initialize that to null pointer. This is basically the same thing we did with the int pointer previously, but we just want to extend this to custom types to really show you this in action. We're going to initialize this to null pointer explicitly, and we're going to make a copy. As you see here, the use count is going to become 4, and we can set up things like this. And if we print the use count, we're going to see 5 at this point here. Let's tidy this up a little bit, and we're going to build and run this little boy here. Okay, the build is good. We can clear and run Rooster. The use count is 5. This is what we want to see here. We can also use a shared pointer to take up memory management for a pointer or a row pointer that has been allocated previously. For example, here we have a dog object which is allocated on the heap through a row pointer. And then we're going to use a shared pointer to take over the memory management job for this row pointer here. Again, this row pointer is going to be still pointing to the same memory location if we don't explicitly zero it out. So what we need to do to be really safe is to say dog ptr, and we're going to say row here, and we are going to zero out this pointer here, and this is going to be safe. Okay, so if we go down here, for example, and try to print out where the row pointer is pointing, we're going to see that it has been zeroed out, and it is not pointing to the same memory location as the shared pointer here. Because if you do something like this, what you really want is to manage the memory through the shared pointer. You don't want to use the row pointer anymore. This is your intent if you do something like this. So we're going to say where the row pointer is pointing. We're going to say dog ptr row, and we're going to print that out. And if we build and run this program, let's do that. We're going to pass this through GCC. The build should be good. We're going to clear and run Rooster. We're going to see that initializing from an already existing row pointer, we're going to call the constructor. And it seems our program has crashed here. What is happening? We have a crash here because we have zeroed out the pointer before we give it to the shared pointer here. So we're going to fix this a little bit. Let's take this line here. We're going to cut it out. And we're going to zero out the row pointer after we assign that to our shared pointer as we do on line 151 here. Let's do this. Now we're going to build and run this program. You see that the program has crashed here. We're going to build again with GCC. The build is good, we can clear, and now if we run, we should see what we expect here. We can initialize a pointer from an already existing row pointer, and we're going to print the dog name through the call we do here, pointer 6. The use count is going to be 1 for pointer 6, that's what we see here. The row pointer is going to be pointing to null pointer because we have zeroed it out. And then we're going to see the destructor for the dog call. We're going to destruct the dog arousal that we built here. And then the dog one that we had previously is also going to be destroyed because all these pointers are going to be running out of scope. We can also do the same things we did with our int pointer previously. So I am just going to put the code here because it really is the same thing. We can reset any of these pointers. This is going to bring down the use count. For example, we reset pointer 5. This is going to reset pointer 5. Its reference count is going to be 0. It is going to be pointing to null pointer, but all the other pointers are going to have a reference count of 4. And if we go down here, we're going to see that we can cast our pointers to bool. This is going to do what we expect. We can go through the get method to get the pointer, the row pointer that is pointed to. And this is something you already know. Let's build and run this. You're going to see that it works exactly as we expect. We're going to clear and run Rooster. And if we go up, we're going to see that we can reset. The reference count is going to go down to 4 and pointer 5 is going to be reset to point to null pointer. So its reference count is going to be 0. And we can cast and use our pointers in if statements. As you see here, dog pointer 4 is going to be pointing to this address. We can print the pointer directly as we are doing here. Dog pointer 4, we can go through the get method. This is going to give us the same address. We can cast. If we cast and the pointer is pointing to something valid, the value is going to be a true. And if we cast and we have a null pointer, we're going to get a 0. And we can go through if statements to know what we are pointing to in our pointer. We can say if dog pointer 5 has been reset, so we know it is pointing to null pointer. So we're going to hit this statement here and say dog ptr5 is pointing to null pointer, and it is what we see here. Once we hit the ending curly brace, all the pointers are going to go out of scope. The reference counts are going to decrement. We're going to hit 0. And we're going to destroy our objects. And you see the destructor called here. You should really know this. Okay, so now we have seen that we can do pretty cool things with custom objects using shared pointers. The next thing I want you to see is that we can also use the make shared facility to set up shared pointers. Let's go on top and comment out what we have here. We are going to scroll all the way down and put in our code. So we are going to say make shared because this is what we want to use. I want to show you that we can do this. We're going to set up a pair of curly braces that are going to be wrapping around our nested scope. And then we're going to put in our code. We're going to set up a shared pointer, int pointer 6, which is going to be pointing to a value of 55 in memory. We're going to say the value pointed to through this pointer. We're going to set up another pointer, which is going to be pointing to a dog object. The dog name is going to be Sauls. And we're going to print the dog information. But notice that we are using make shared. We can do this. And we're going to print the use count. This is going to give us 1 because at this point we have each pointer pointing to one piece of data in memory. So let's build and run this. We should see this running in a minute. The build should be good. So we're going to clear and run rooster, and we're going to see that we have the value pointed to is 55, which is what we get from this line here. We're going to print the dog name, which is going to give us Saul's, and all these pointers have a reference count of 1 because we have one shared pointer to int pointing to this value. We have one shared pointer to dog pointing to this dog object here. And this is what we see. Once we hit the end of the scope here, we're going to see that the destructor for our dog object is going to be called, and that's what we see down here. We can make copies of these pointers, so let's go down and do that. We can take out our PowerShell window here. And we're going to set up another shared pointer, which is going to be initialized to null PTR. The data we have in int pointer 6 is going to be copied in int pointer 7. We're going to do the same thing for our dog pointer. We're going to set up a new shared pointer to dog. And then we're going to copy the data from pointer 6 in pointer 7. And now the reference count is going to go up to 2 because for each of these pointers, we have 2 pointers pointing to the same data in memory. Let's build and run, and you're going to see this in action in a minute. So the build should be good as you see here. We're going to clear and run rooster. This is going to give us a reference count of 2 for a dog pointer and a reference count of 2 for our int pointer. And this is what you see here. And once we hit the end of the scope, as usual, the dog object is going to be destroyed. We are really also releasing the int memory, but we can't really see the destructor for int because it is a fundamental type. But know that the memory is going to be released if you are managing the memory through a shared pointer and the reference count has hit 0. As you hit the end of the scope here, this is going to release your memory, and that's why we see the destructor for dog called here to release the memory. Okay, we can also do a reset on a piece of memory we got through make shared. So I am going to put in a piece of code to show you that. We have the code here. We are going to reset the pointer 6 for int and the pointer 6 for dog. And this is going to bring down the reference count, and we're going to see a reference count of 1 printed out at this point here. So let's build and run this program. The build is good. We can clear and run rooster. This is going to give us a reference count of 1 for pointer 7s, and for pointer 6 for dog and int we're going to get a reference count of 0 because resetting the pointer is going to reset the pointer to point to null pointer. It is not going to be pointing anywhere, so the reference count is going to be 0. That's why we see a 0 for pointer 6 to int and pointer 6 to dog. This is really all I had to share in this lecture. Again, I apologize. It turned out to be lengthy, but we really had a lot of things to see about shared pointers. If you have any problem, please don't hesitate to ask, and I will do the best I can to help you out. We are going to stop here in this lecture. In the next one, we're going to see that we can actually create a shared pointer from a unique pointer. And that's really interesting. So go ahead and finish up here and meet me there.